Hi, all. Good morning, and welcome to this live stream on OpenTelemetry. I'm so glad to be presenting about OpenTelemetry today morning. Basically, what we are going to cover today is the basics of tracing, and I will, in particular, cover an tracing solution which is based on OpenTelemetry. And by the way, OpenTelemetry is fast becoming as the go-to solution for an open and standardized way of implementing observability for cloud native applications as well as infrastructure. So today you will be able to walk away with a very basic and fundamental understanding of what distributed tracing is and the benefits, or when you will feel the benefits of using distributed tracing. And you will also gain a very good understanding of the basics of open telemetry, and you will know even how to implement an open telemetry solution. Okay, and I will be actually finishing the presentation off with a very simple demo. So I'm actually excited to start the presentation. Okay, so basically, today we are going to cover the basics of open telemetry tracing: what, why, and how. And a little bit of introduction about me. I am Senthil. I work as principal software engineer in Ericsson. Basically, I'm responsible for architecting and designing AI/ML solutions on top of Kubernetes. Apart from my active day job, I am also the organizer of Kubernetes Community Days. So in 2023, that is this year, we are actually in the very initial stages of preparing for KCD Chennai 2023. So the information will go out very soon. And I'm the maintainer of an open source project called as KubeFledged. And KubeFledged is all about being able to cache container images directly on the worker nodes of a Kubernetes cluster, so that application pods will be able to start up very quickly. And I have interest, of course, in Kubernetes and the wider cloud native ecosystem around Kubernetes. And of course, I have special interests in MLOps. By the way, MLOps is all about how do you productify and how do you industrialize the entire process of running machine learning models in production. And very recently, I'm also very interested in WebAssembly as a technology, how it will shape up the future of computing itself, and how it will coexist, or even sometimes even replace containers eventually. Okay. Right. So that's a little bit about me, and I'm available on various social media platforms, Twitter and LinkedIn. I'm very active in Twitter and LinkedIn, and you can also find me on Medium, posting some blogs, and of course in YouTube. Right. So let's get into the agenda. So the agenda for today is as follows. We are going to look at metrics, logs, and tracing. So I'm actually looking at explaining to you when to use metrics, when to use logs, and when you will essentially require tracing as well, and followed by an introduction to OpenTelemetry. I will cover some basic concepts about OpenTelemetry tracing, like traces and spans. And very importantly, there is a concept called as context propagation, and that is a fundamental concept that underpins distributed tracing using OpenTelemetry. So I will cover about context propagation, and I'm going to show you some code snippets in Golang, which will help you understand how to instrument the code, how to instrument the code for OpenTelemetry distributed tracing. And I will also talk about OpenTelemetry collector, which is actually a component from the OpenTelemetry open source project itself. And I will actually finish off the presentation with a demo. And by the way, if you have any questions, please feel free to post those questions directly in the YouTube chat. And at an appropriate point in time, I will actually pause the presentation and answer the questions that you post in the YouTube chat. Now, first of all, you might be very familiar about metrics. Okay, let's say you have a distributed application which is made up of multiple microservices, right? And there is a request that is sent to the application, and in this case, the request comes to microservice A, and it traverses various different microservices, and then the final response is sent by microservice A. And let's say there is a delay in receiving this response, and you as an application developer, or perhaps as a DevOps engineer, you want to understand where the bottleneck is, right? So which particular microservice is causing this delayed response? So obviously the natural go-to solution or the natural troubleshooting mechanism that you will prefer in this case is metrics. So in case if microservice C emits metrics, so you can look at the metrics from microservice C and look at how the latency metrics looks like. Okay, so once you see the metrics, you can readily understand that the bottleneck is at microservice C. Okay. So in this way, metrics can help you to actually figure out performance bottlenecks. Okay. And in this case, it is possible only if the problem is reproducible. So for every request that the user sends, if the response that is sent by the application is always delayed, then you can very easily rely on the metrics to figure out which microservice in this chain is actually causing this bottleneck. Okay, so metrics will be sufficient for you to figure this out. Now, let's say you want to figure out why microservice C is sending a delayed response, right? And in that case, you will have to look into what's going on inside microservice C. And that is when you will rely on logs. Okay. So you will fetch the logs of microservice C, and probably you will look out for log messages which will indicate the possibility of an bottleneck. And this way you can figure out that what is really happening inside the microservice C, that it sends a delayed response. So basically, with a combination of metrics and logs, you will be able to figure out which microservice causes the bottleneck and why it causes the bottleneck. Again, I'm assuming in this scenario that the issue is reproducible. So if the issue is reproducible, and you can very well rely on metrics and logs, to pinpoint what exactly is happening and why it is happening. Now let's switch gears, and let's say the problem is not reproducible, and the problem is really intermittent. Okay, let's say you deploy this application in a production environment, and you happen to see intermittent requests receiving a delayed response, right? So naturally, in this situation, you might not be very productive if you are solely relying on metrics and logs alone to understand why this problem is occurring. Because microservice C in this case will be accepting n number of requests. Okay, and for you to figure out which particular request is subjected to this delayed response just by looking at the logs is actually very difficult, if not impossible. And this is where tracing will help you, because tracing, when we talk about tracing, what it does is it actually generates a trail. Okay, it generates a flow of the request itself, that is passing from microservice A to microservice B to the database, and then finally to microservice C, and then microservice C calls the database. So tracing will help you to easily visualize the complete path the request takes. And not only that, tracing will also help you to understand what is really happening within the microservice C. and and you can actually select a particular request, right, and then see the trail of that particular request alone. So this way you can actually select the failing request or the request that is getting the delayed response, and then you can actually see the trail of that request into the system. So this way you can easily figure out why this intermittent failure is happening. So that is where tracing will help you. So without tracing, it is actually impossible for you to figure out what is really happening and troubleshoot this problem. So if you are relying on metrics and logs alone, perhaps perhaps if it is someone who knows about the system very well, or if someone is willing to spend the enormous amount of time, you know then perhaps you will still be able to do it with metrics and logs alone, but that is not the productive way of doing it. And this is the sweet spot that distributed tracing is trying to fill in. And tracing becomes a fundamental piece now on the overall observability solution. And you can see the tracing getting implemented in various cloud native applications. And obviously, open telemetry has become the natural choice for implementing distributed tracing. Okay, so I'm going to just talk about open telemetry now. Now that you have an understanding of what are the benefits of distributed tracing, and let's dig more deeper into what open telemetry is and how open telemetry solves the problem of distributed tracing. And again, if you have any questions, please feel free to post them in the chat box of YouTube, and I'll be more than happy to answer your questions. Right. So let's continue. So, what is OpenTelemetry? Basically, OpenTelemetry is an observability framework that helps you in generating, collecting, and exporting telemetry data. So, what are the telemetry data that we are talking about? It is basically traces, metrics, and logs. And the beauty of OpenTelemetry is it is, first of all, open source, and it is also vendor neutral. The reason it is vendor neutral is that the telemetry data format that OpenTelemetry defines is actually a standardized format. And almost every open source observability vendor, or even proprietary observability solutions, are supporting the OpenTelemetry format. Okay, so which means you don't actually get locked into a particular observability framework. For instance, if you have spent enormous amount of time in instrumenting your application using a library of a certain open observability framework, right? And that will work only if the observability backend is also supporting that framework. But that is no longer the case with OpenTelemetry. You can instrument your code with OpenTelemetry, and you can be rest assured that the instrumentation will work fine with any observability backend that supports OpenTelemetry. So that is a very big advantage that you get with OpenTelemetry. And as I said, in the past, the way before OpenTelemetry observability solutions were implemented is to use vendor-specific instrumentation libraries. So these vendors, for instance, Jaeger and Zipkin, um, like they provided their own instrumentation libraries with various programming languages, with support for various programming languages, and one has to choose which particular solution they want to implement, and has to use the instrumentation libraries of that particular tool, right? So which means the instrumentation itself is not portable across the different solutions. So OpenTelemetry's primary goal is to provide a set of standardized and vendor agnostic SDKs, APIs, and even tools. It not just stops at providing you with these APIs and SDKs and instrumentation libraries. OpenTelemetry also provides you various set of tools with which you can actually implement an OpenTelemetry tracing or logging or metric solution. So that's the advantage of OpenTelemetry. And by the way, OpenTelemetry is a CNCF project, and many vendors, even Jaeger, Zipkin, Grafana. So there are a whole bunch of vendors, observability solution vendors, who are already supporting OpenTelemetry. So if you are actually starting out with implementing observability for your applications or infrastructure, it is very, very preferable for you to start with OpenTelemetry, because there is a wide set of support from vendors, and there is a wide set of programming languages supported by OpenTelemetry. Right. Now let's get into some of the concepts that you will come across in OpenTelemetry. So first of all, there is this notion called as trace. Okay. So what is a distributed trace, or more commonly known as trace? It actually is something that records the paths taken by requests as they propagate through different microservices. Basically, a trace is a piece of information. Okay, and this will actually contain the paths taken by the requests as it traverses the various microservices. And not only that, what happens within a microservice is also captured within the trace. So a trace is a very fundamental part of OpenTelemetry. And the next thing is span. A trace is, by the way, made of one or more spans, right? Fundamentally, it is spans that make up a complete trace. And by the way, what is a span? A span actually represents a unit of work or operation. So you can design your instrumentation, you can design your solution in such a way that you get to choose what will constitute a span, right? For instance, if the application is making a request to a database, right? So that is actually considered as an unit of work or an operation. So you can actually have a span to track that operation. Okay, let's say your microservice is calling another microservice, right? So that is an operation. So you can have a span to track the microservice A sending this REST API call to microservice B. So you get to choose what are the spans that you want to track as part of the trace. Okay, and spans typically contain time related data. For instance, it will have a timestamp, the start time, and then the end time of the span. And it will have structured log messages. You can also have something like events. A span will generate events, and these events can even have log messages. Okay, and spans will have a whole bunch of metadata, which is called as attributes in OpenTelemetry. OpenTelemetry itself defines a set of common attributes. Okay, and in on top of that, you can also have your own metadata, which is very specific for your needs. Okay, and basically it is the span, that actually keeps track of work. Okay, so basically span is the fundamental unit within OpenTelemetry that keeps track of work or operation. And OpenTelemetry trace is something that collects all these spans, and then in a coherent manner it combines all these spans into a specific trace. Okay, so a trace is identified by a trace ID, and then a span is identified by a span ID. Okay. So this is about traces and spans. And let's now continue. So this is a sample trace that you get out of OpenTelemetry. So now that you have an understanding of OpenTelemetry, and just now we saw the concept of trace and span, I think it's time for us to take a look at a sample trace. This is the sample trace that I wanted to present. This is again in JSON format. Here, there are some important pieces that will help us to understand basically traces and spans. Okay. By the way, to start with, this is a very, very simple trace, and this trace happens to contain just a single span. Okay. And there is an important field called as context in this span. So this context has a trace ID and then a span ID. And the context is a very, very important piece in OpenTelemetry. And it is this context that actually helps in tying together all these various spans coherently into a trace. And it is this context that helps you in doing a distributed trace. So there is something called as context propagation, which we will talk about later. Basically, this context can have other information as well, but the most important information a context holds is the trace ID and the span ID. Okay. And of course, a span can have attributes. So in this case, this span has a single attribute called as http.route. So it actually captures the route name that actually handles this request. And beneath attributes, you will see events. Okay. So events are like more verbose information that you want to attach to traces. Okay. Um, so attributes are basically metadata. So you can attach metadata to spans. You can instrument your code in such a way that metadata is captured automatically within the spans. And you can also choose to generate events which are basically log messages. So if you want to associate more information, right, more verbose information, and you also want to attach metadata that is very specific to those events, you can also do that. That is the purpose of having the event section. Okay. Yeah, so basically important fields are context, attributes, and events. Okay, so this is a very simplistic open telemetry trace. And it's now time to see what context propagation is. Okay. So context propagation is the fundamental piece of open telemetry that helps in, knitting all the spans together and then providing you this visualization of what happens to the request, what are the various microservices the request traverses, and even what is happening within a specific microservice for that request. Okay. So all this is actually underpinned by context propagation. So let me spend some time on explaining what context propagation is all about. Okay. So we know span is the fundamental piece, right? So span. So what happens is whenever there is a span generated by an application, right, there is always a context associated to it. Okay. And context is an object that contains the information. So whatever information is required for the sending and receiving service to correlate one span with another, and finally associate the span to the overall trace. So whatever information is required to perform this correlation, so that information is actually put into this context. Okay. And by the way, it is a software object, and this object gets serialized and deserialized as the request propagates through the system. Okay. So if there is a request that goes from microservice A to microservice B, so naturally what would happen is microservice A would generate a span, and this span will have a context. Okay. And when this request goes to microservice B, let's say using an REST API call, okay, which is actually sent over HTTP. Then what happens is this context object at that point in time gets serialized, and it will get added into a particular HTTP header of the request. So OpenTelemetry also defines some of the headers which you can use for this context propagation. And by the way, you don't have to worry about all these things in your code. So it is handled transparently for you by OpenTelemetry. So there is a serialization part that happens in microservice A, and there is a corresponding deserialization that happens in microservice B, which actually creates this context object. Okay, and this context object will then be used by microservice B to generate a new span. All right. So basically, the for you to visualize, so there is always a context that gets associated with this span, right? And this context is always sent from one place to another. So wherever the request traverses, right? Wherever the request traverses, this context also goes along. So that is what is called as propagation. And actually, OpenTelemetry actually defines, and it actually specifies, and it actually handles this propagation for you. So you don't have to do anything at all apart from using the OpenTelemetry instrumentation library. Okay. So propagation is the mechanism that moves context between services and processes. So context propagation is applicable both within a microservice. So when there is processing happening within the microservice, and you want to keep track of this processing at various points in time, right? So that is also an instance where context propagation is involved. So only thing is this context propagation happens within the process itself, within the microservice, right? Whereas the propagation is also equally applicable when the spans traverse, different microservices. And and because of this propagation only, open telemetry is able to provide you with this distributed tracing solution. Basically, what open telemetry does is, as I said earlier, it serializes or deserializes the span context and provides the relevant trace information to be propagated from one service to another. So basically, when I started with studying open telemetry, I mean, I started with looking at the UI and then visualizing the traces and spans. I was really thrilled, and I was actually curious to know how open telemetry is able to keep track of the request as it traverses to all these various microservices. And that is when I understood that it is all because of the context and because of the context propagation. And by the way, this is all handled. The context propagation is handled totally by open telemetry. You don't have to do anything at all to do context propagation. All right. Okay. So let's move ahead. So I'm going to actually try to explain you some code snippets, okay, where you will get to understand how instrumentation is done. So let me actually explain about what this term instrumentation means, okay. So first of all, if you need to implement observability of an application, let's say, or even an infrastructure, right, basically you need to instrument the code. Okay, so instrumentation is basically you write some code which will actually be responsible for generating the traces and spans. Okay, sorry, generating the spans. Okay, because a trace is not something that the application generates. Trace is something that is generated based on the spans. So the application will be responsible only for generating these spans. So let's start with this very simple code. So by the way, this is a Golang code, and there is the run method. Okay, so there is a run method which is actually responsible for running the application, and there is a poll method which is actually doing some work within this application. Okay. So the run method is the one that is started as when the application container is starting up. So here you can see that there is a statement, new ctx, new context comma span equals OTel dot tracer, and then there is a start method that is called. So if you can see here, so this run method itself gets a context, okay? And it is actually implemented using Golang's context library. So the run method itself gets a context, and this context is in turn used to create a span, okay? So here you can see that the context object is passed to the tracer's start method, and this actually returns you a new context, okay, and then a span. Right. So at this point, what happens is a new span is generated. Okay. A new span is generated, and this new span has a context associated to it. And whatever information is required for correlation is already present within this context, which is basically trace ID and span ID. Okay. So that is all the rest, that is all taken care by OpenTelemetry. Okay. And subsequently, in the next statement, you see that this method calls the poll method. Okay. And when this poll method is called, the new context that was returned by the OpenTelemetry tracer is sent. Okay. So this is where context propagation happens. So basically, whatever context that was returned by the span that was created in the previous statement, that context is now passed to the poll method. And on the right hand side, you can see the poll method itself, which actually receives the context. And using that context, the poll method creates another span. Okay. And what happens down is basically some attributes are being set. Okay. If you remember the trace that I showed you in the previous slide, there were attributes associated with the span. So the attributes are basically set using the set attributes method of the span. And again, you see that in this method also the context is being used. So the context is very fundamental to instrumenting the code, and you need to make sure that the context, whatever methods that you have in your code, receive a context parameter, and then make use of that received context to create subsequent spans. Okay. um, and by the way, this is not the complete code for instrumenting an application. So these are just code snippets for you to understand basically how the code is instrumented. Okay. Uh, Perhaps if you want to understand uh, all the steps that are involved in code instrumentation, that itself will be a different presentation. Okay. So you can actually look up in opentelemetry.io, and there is a very good complete example of how to do code instrumentation in Golang. So you can take a look at that. Right, let's continue. So now we have an understanding of traces and spans. We had a look at a sample trace, and we understood the importance of context and the importance of context propagation. And we also had a look at an code snippet where the context was, where the span was created and where the context was used to create further spans, and how the context was actually propagated from one method to another method, right? So with this fundamental knowledge, I want to introduce you to a component that is called as OpenTelemetry collector. Okay. So this is a component, it's a binary. You can deploy it as a container or a pod in Kubernetes. And in fact, this component is actually delivered by the OpenTelemetry project itself. Okay. And you can actually run this component in various modes. You can run it as a standalone pod within your cluster. You can even choose to run this as a node agent. Okay. So every node in your cluster will have an OpenTelemetry collector, and the purpose of OpenTelemetry collector is to collect OpenTelemetry data, and it can be configured to do some processing of this open telemetry data, and then it can also be configured to export this open telemetry data to various backends. Okay, so basically open telemetry collector will actually be responsible. It will actually be responsible for collecting the open telemetry data, for doing some processing, and you can actually configure to export the data to various backends. Okay. And by the way, Open Telemetry Collector is not a mandatory component that is required for you to implement an tracing solution. So the application code can even be directly configured to send the span data directly to the Open Telemetry backend, or directly to the observability backend. In this case, if you are using Jaeger, the open telemetry spans can directly be sent to Jaeger directly via the OTLP protocol, or you can choose to have an open telemetry collector collect the trace data, do some pre-processing on that, and then send the data back, and then further send the data to Jaeger. Okay, and here you can see that the communication from the application code towards either the open telemetry collector or the backend is via something called as an OTLP protocol. OTLP is nothing but Open Telemetry Protocol. This is a protocol specification which is based on gRPC, and this is specified by the Open Telemetry specification itself. And it is actually based on gRPC. Okay, so there is a protobuf structure that is defined by Open Telemetry, and you can this is called as the OTLP, Open Telemetry Protocol. So it basically works on top of gRPC. Okay. And Open Telemetry Collector itself has three different stages. The first one is receivers. So Open Telemetry Collector can support not only OTLP format, it can also support other formats of telemetry data like Jaeger or Prometheus or Zipkin. So there are different set of receivers. You can configure which receivers to activate. So if you choose to have only Open Telemetry format to be supported, you can actually specify that in the configuration file, or you can also even use Open Telemetry Collector to collect to collect telemetry data in other formats as well, like Jaeger, Prometheus, anything. And then the next piece is processors. So processors are basically data processing, or whatever you want, whatever kind of processing that you want to do on the data, you can actually do. So it supports various processing like scrubbing, manipulation, batching, sampling. So if you want to send the data in batches, okay, not necessary to stream the data as it comes, then you can actually configure the batch size and things like that, and the collector will actually take care of batching. Okay, and then you can actually configure various exporters. Okay, it's not that you can only send the processed data to a single backend. You can configure many different backends and the endpoints of all these backends with the configuration, and the collector will send the data to all these various backends. Right. So this is all about OpenTelemetry collector. And yes, now we are ready to do the demonstration. Okay. So what I'm going to do is I'm going to open my terminal, and let me actually share my terminal window. Okay. Share. Right. So I have actually installed a demo application, which is already running in my Kubernetes cluster. You can see it here. I have installed it in a namespace called as OTel. And this application is actually a microservices based application. So it contains various microservices. You can see there is a whole bunch of microservices running as part of this application. And this is the microservice that we will be using for this demo. So our objective in this demo is to see or to track a request that comes to this front end microservice and see how this request traverses through this application. So in this demo, what I'm going to do is I'm going to fire a HTTP GET request to this front end microservice. And this microservice will in turn contact the product catalog service that you see here, and then it will fetch the details and then it will send out a response. Okay, that is what I'm going to do for this demo, right? And here you can see that I have already installed OpenTelemetry collector. So this is the OpenTelemetry collector that is running, and the backend that I'm going to use is Jaeger, and you should see the Jaeger also running here. Okay, so you see, so basically the application is ready, the Open Telemetry collector is ready, and also the backend is also ready. Okay. Now, basically what I'm going to do now is instead of sending a single request, I'm going to send a bunch of requests. So which means I'm going to generate load on this application. So I'm going to start the load generator. So this is again a microservice. The purpose of this microservice is to generate requests that go to the front end microservice. Okay. Let's see if the load generator is up and running. Yes, it is. So the load generator is now up and running. Right. Now we are ready to start the demo. So this is the environment and now the load generator is running. And I'm going to actually next open the Jaeger UI and see, and I'm going to actually show you the various traces and how to query the traces and how to see the span. So I'm going to now um share my browser. Yes. Right. So before that, I need to do some port forwarding because I need to open the UI of Jaeger. So there are some port forwardings that I need to do. So I'm going to do that now in a separate terminal window. You won't be able to see the terminal now. So what I'm doing now is I've opened a terminal and I have to do a couple of port forwardings. So the first one is done and I'm about to do the second port forwarding. Okay, so it's done. Okay, so now um, we are ready to go. So I'm going to use Jaeger, and here you can see the Jaeger UI. All right. Um, and there are various services, as I told you, right? So this application contains various services, but for this demo, we are going to use the front end service. We are interested in tracing this front end service. And here you can see there are various operations. You know, Jaeger has picked up various operations. And let's say I want to trace a HTTP GET request. Let's say there is an issue with this particular service not handling the GET properly. And let's try to find out what is happening. So when I say find traces, it has given me a list of traces. So you can see here that it has given me a list of traces, and all these traces are generated very recently once I have started the load generator. Okay. Let me pick this one. This has a decent number of spans. Okay. So as you can see, this particular trace, right? So what we have done is we have selected a particular trace. So we have queried the list of traces that are present, and we have selected a particular trace, right? So here you can see some information like duration. So this entire trace duration is 2.39 millisecond, and it traverses two services. One is the front end service, another one is the product catalog service. And here you can see that it has in total three spans. Now, these three line items that you see here, right? These are the three spans. So I'm going to click on the first one. So here you can see the span ID, right? So here you can see the span ID, and whatever data that you see here is actually generated as part of the span. So here you can see various information. For instance, it is a get method, and there was a response code of 200. What is the target? What is the URL and all these other details? And it can, and here you will also see other details like what is the container ID and OS type and what are the various versions. So here you will be able to see the OpenTelemetry version as well. Here it is. So here you see that this is actually OpenTelemetry version 1.8.0, and it is actually Node.js. Okay, so which means this service is a Node.js application, right? What do we see in references? Yeah, span in another trace follows from. Okay, so it says that basically it is a follow-on span. It is not a root span, and it is a follow-on span. Okay, that is fine. So now what happens is, what this span means is, this span is basically tracking the HTTP get. Okay, so whenever the front end service receives a HTTP get request, the span is generated. So the span is said to be tracking the HTTP get request. Okay, now let's see the second span. So this second span again is from the front end service. Okay, and this span is actually tracking the grpc request that is about to be sent to the product catalog service. So this span is basically tracking the sending of this request to the product catalog service. Okay, so that is what this is tracking. So again, if you see inside tags, so here you can see details that are related to this span. Okay. For instance, it says that this is the remote procedure call that is about to be called, and this is based on gRPC. Okay. And things like that. Okay. And so here, basically, what I understand is the front end service is receiving a HTTP request. And then once it receives a HTTP request, what is internally happening within the front end services? It is about to send, or it sends a gRPC request to the product catalog service. That's what I can learn until now by seeing at these two spans. And then the third span is actually generated by the product catalog service. Okay, so which means there is a context propagation that has successfully happened. The context has propagated from the front end service to the product catalog service. And here I can see in the third span, um, I can see the tags, I can see the process, and I can see the, interestingly, this span has generated log messages. So it has generated in OpenTelemetry parlance, it is called as events. Okay, so it has generated three events. In the first event, it is actually a message, and then it says some information on what this event is all about. Okay, similarly, there is a second event, um, and then it says something about the product itself. So it says, I received a request, and this is the product ID. I found this product ID. Okay. So these are something like log messages. Okay. The log messages that are attached to these spans itself. Okay. And then there is a third message that says sent, which means it is probably sending another request to some other service, and that is not tracked. Okay, so if that is also tracked by a span, you would have seen a fourth span. Okay, so probably what is happening here is there is a response sent back to the there is a response sent back to the front end service, and that is what is probably you are seeing it here. Yeah. So this is a very simple trace that you can see. And I can see that this trace has three spans. And the first span tracks the HTTP GET in the front end service. The second one tracks the gRPC call to the product catalog service. The third one actually tracks the gRPC call getting received in the product catalog service. Okay. And we could also take a look at other traces. Here you can see that various traces are getting generated. And here we can also take a look at what is really happening here. So in this case, what is happening is the front end is receiving HTTP GET. And obviously, this time there is a request that goes to the add service. Okay. And from the add service, the request is sent to the feature flag service. Okay, and finally you can see that the entire duration takes 9.18 millisecond. Yeah, so this is all about tracing, right? And by the way, for this demo, I have used Jaeger. Apparently, there are various other backends that you can use for OpenTelemetry. You can use, for instance, Zipkin. You could use Grafana Tempo. Grafana has a separate backend for tracing, which is called as Grafana Tempo. You can use that as well. Basically all open source solutions and all vendors are currently supporting open telemetry. Okay, fine then. So the demo is over, so I'm going to now stop sharing this screen. Let me see if there are any questions. Yes, Anshuman. Hi, Anshuman. Welcome. So, Anshuman has actually asked two questions. Let me take the first one. How OpenTelemetry CLI in GCP Cloud Shell is being migrated with a K8s VM instance running compatible API in a region with downward GUI API enabled for it partially. Okay. So Anshuman wants to know how OpenTelemetry CLI in the GCP Cloud Shell is being migrated with the K8s VM instance running compatible API. Okay, so I understand that this is a very specific question. So Anshuman would like to know how the OpenTelemetry CLI that is provided by GCP is being migrated with the K8s VM instance. I understand this is a very specific question of how OpenTelemetry CLI is being used in GCP, and I frankly don't know how this migration works. And Anshuman would also want to know VM instance running compatible API in a region with downward GUI API enabled for it particularly. I'm extremely sorry, Anshuman. I'm totally blank on this because I'm not familiar with using OpenTelemetry CLI in GCP. So I will not be able to answer this question. So let me take up the second question from Anshuman. So, any Terraform CLI for OpenTelemetry of AIML web applications? Yeah, that's a good question, but I haven't actually come across any Terraform CLIs or Terraform commands that you can use. But that's a very good point that you have raised. Let me look up on this, and whatever I find, I will post it in the comment section so that you can take a look at it. But actually, it's a very good point. If OpenTelemetry provides some inbuilt integration that can be used, that can be invoked from Terraform? Okay, that's a good question, Anshuman. By the way, thank you for joining this stream and for your informative questions. And by the way, we have reached the end of this show. So if there are no further questions, I would like to thank you all for joining this live stream, especially on a Saturday morning. And I really appreciate taking your time to learn something about open telemetry tracing. I hope you had a good basic understanding of distributed tracing itself in general, and in particular about open telemetry. And by the way, if you have any further questions, we can jointly explore open telemetry. So feel free to contact me either via Twitter or LinkedIn. And feel free to subscribe to the channel as well, because I plan to keep posting videos and live streams in regular intervals. So thank you all. Thank you for your time. So let's keep learning. Thank you. Bye bye.